Even make sure that I'm streaming yet. Don't know until we know. Look at there, we're live. All right, hey, welcome back. It's Tuesday, and we're getting back into EXAPUNKS. Last time we played through quite a few levels. Well, I say quite a few. We still have at least a lot of game that I'm aware of. But we did play through a good chunk of levels. Mostly tutorial stuff and kind of entry-level stuff. We haven't even gotten to the battles yet, which will be fun. Oh, it looks like we get the second issue of Trash World News now. That's exciting. Let's see. Before we go into the new levels, I kind of had a spark of inspiration since the last stream on how to solve some challenges in a little bit more of a creative way. So I think one of these early missions involves counting. Is this the one that involves counting? It is not. So I have this idea to kind of, I don't want to say abuse, but it's kind of abusing the T register and F jumps. I don't remember where this was at. At one point we definitely had to count. Maybe not, though. Learn to do something. Oh, there we go. Yeah, so this is counting. This is the simplest level I could think of to try this out on. But what we do here is we have this loop block that we copy the value from the file, and we copy the value into the file. We subtract it. We test if it's less than 0 because we want to write 0, and then we F jump. So what I'm thinking is, if we instead just didn't test, right? So a value of 0 will be false. So if we start by writing the value there, then we subtract and we write the value in the loop. If we then T jumped back to loop, that should fail when we hit 0. So, oh, you know what? We have to change the register that we're using to T in order for this to work. So we'll be using T, T, T. No, this was T to F. Yeah. Alright, so now if we try that, we get 9, we get 8, we get 7. It seems to be working. And then once we hit 0, 0 is no longer true. So we don't jump. Boom. I'm wondering if that's going to increase our cycle count. Absolutely, that dropped us down. Not as performant as we could be, but you can see we've broken that large average there of cycle count. We saved a little over 100 cycles. So that's pretty cool. Hey, welcome back. Thanks for tuning in. Hopefully we're in for a fun day. Just trying out some crazy idea I had. Turns out it works. Let's see. Hack your heart so it continues to beat properly. Okay, well that's a problem if your heart's not beating properly. So we're going to be hacking our heart. It'll probably be fine. Don't tell me. You die? I guess that explains some things. How does the AI not already know that? More or less. Yeah, you probably should learn more about it. Okay, so we've got 3 nerves this time. So what do we need to do? Read a value from the nerve connected to your central nervous system. So here. And make your heart beat by writing a sequence of values to your sino atrial nerve and your atrioventricular nerve nodes. So as indicated in the HDI-10 IO logs, when holding this shall go. The length of each sequence of values should be equal to the value from CNS divided by -10. It is not necessary to leave no trace. So let's see, what do we have? We write 42. We want to write 40. Okay, maybe I need to read that again. I think I missed it. Okay, so we're read a value from CNS and make your heart beat by writing a sequence of values to these two, as indicated by the app. Okay, so it's not really telling us what we need. So we read 42, we beat 40, -70, then -70, 40, then -70, -70, then -70, -70. So 4 times is what it seems like. We start with 40, but then we only swap 40 twice, and then we get -70s for all the other entries. Interesting. So that should be 1, 2, 3, 4, 5. I can't hold this and mouse over the goals at the same. Oh, here we go. We can do that. Okay. Yeah, that's perfect. Yeah, so 42 divided by -10 is, yeah, divided by -10 is going to be 4. So that's 4, 1, 2, 3, 4. Of course, the first one's always 40, -70. The second one is always -70, 40. And we've got -64, so that's 6. That's 1, 2, 3, 4, 5, 6. And of course, the first two have a 40, but the rest are all 70s. And then this would be 9. That would be 6 and 5. So that should be it. Just to confirm, we got 3. Do we have any that are 2s? Any test cases with a 2? Looking for a 2. 2, 2, 2. I don't see any with a 20 in it. Interesting. So it seems like we'll always get to the loop portion. Anyways, we've got some communication troubles, because if, like, we don't want a node, like, we don't really want X's running around rampantly, but we also don't want X's, like, reading each other's messages, I guess. Well, we kind of do. We're gonna need 3 for this one. So I think for AVN, we'll do B. So that's gonna link 800 to get us into the body. Link 3 gets us over to the atrioventricular. Perfect. And then we're gonna do mark main loop, and then we'll have like a mark, just mark loop. So in the main loop, we want to copy M to T. We're going to do T for our count. And this is the AV in, so this is the one that does 40-second. So the thing that we want to do is we want to, we actually don't want to copy. We want to divide M by -10 and store the result in T. Then we can swizz. We want the tens digit, which would be 1, 2, because it starts on the right side. 1, 2, 3, 4 digits, right? So T by 2 back into T. So that gives us the tens digit as a 1. That's kind of our modular division approach. And then we want to simply count that down. We can go ahead and subtract 2 from it. So we'll sub I T to T. The reason why we're going to do that is we're going to copy. First we write -70 to nerve. Then we're going to copy 40 to nerve. And then in our loop here, in our mark loop, we're just going to copy -70 to nerve. We're going to sub I t by 1, and then we're going to t jump back to loop, and then here we'll jump main loop. Yeah. So that's using our new counting trick, and it's going to be a similar pattern for the what was it called? Sinoatrial. So that's link 800, and then we link 1 and then this will divide M10. We can go ahead and collapse that one for now. It's going to do the same work, and then -70 and 40. So this is going to be the inverse. We write 40 first, then we write -70s. So we only need to subtract 1 from this one, since we'll just roll that into the regular 70. Okay, so here what we'll do is we'll link 800, and we'll copy nerve into X, and then we'll copy X to M twice. And that is all we do. If we spell copy correctly, it should work. Always want to spell copy correctly. Okay. So that should come in. We get here. It reads 42, -42. We broadcast it. One of them, it doesn't matter which one, they'll both be competing. One of them will read the first one. One of them will read the second one. So they write -70 and 40. And we're looking correct. We went too far. What happened? Let's start over. Okay. We are at, why are we at 2? We divide M by -10. That gave us 4. Okay. So I'm not thinking correctly here. We already have kind of integer division going on. Yeah, perfect. That way. There we go. Now the problem is this node is 3 ahead, which I think is going to be very problematic. It's going to start eating these values, and we're going to get some incorrect inputs. So like here, this one has started to move, and now it's done. It's going to read the next value, which it's done. Maybe it's not an issue. Yes, there we go. We had an issue. Why are you so far ahead? You're at least 1 ahead. So what if we artificially slow this one down by doing a void? No, not a void. I think it's just wait, maybe? No. What is the command? We will have to return to our desktop so that we can access the digital version of this document again. Then we can go back into that level. Okay. We have returned. Let's get this browser piece set back up. And lessons learned, we're not going to leave it on. There we are. Okay, yeah, we're not going to leave it on while we play. Okay, so we're looking for the language 14. Yep, 13, yeah, 14. Okay, so we want a command that gives us, that does nothing. It's just no op. It is no op. Okay. How creative of a command name that was. No op. Interesting. So let's delay this one to try and get it in line. It's still red first. It's still in the lead a little bit. So once it gets there, what if we delayed that? If it gets there, right? I think we're gonna need to no op twice. I just kind of want to sync these two up a little better. They're still not synced up very well. And what is the reason for that? Those 40s are in there to just like throw you off, right? Because this one just writes 40 and then negative 70. And then this one, what if we did the same thing here? We just started off, we wrote a negative 70 in, and then it is the same. So we already have an extra copy right there at the beginning. It is still ahead. It is still ahead. Synchronizing these things is a pain. That looks more in sync. Okay, let's run that. Yeah, we're doing a lot better. Okay. Okay, we did it. All right. Cycles, we're average. We got average. Average everything. Yeah. Not sure there's a better approach that I could think of off the top of my head. Oh, this is a good question. Do you ever wish you were a computer? Process a bunch of information. Functioning computer. Yeah, I mean, I'd rather be a computer that doesn't function. That would be great. I never wished for a human body myself. Well, you'd probably, you know, depending on what kind of AR you are, you probably have to be trained on that. All right, we got some more chat messages coming in, so nobody wants to join me in King's Random online. That was King's Ransom. It's a distraction from being the best hacker. Haven't laughed that hard in a long time. I think at one point they start taking some credit for some things that you do. Someone found a bunch of my network nodes and sent in a tip to Ghast. Too bad I can't have people knowing about me. You're gonna have to hack me out of that message. All right. So we've got Ghast here. What did they... Okay, so find and replace the keywords in the target message, file 212. This is the target message, as directed by Ember 2. A list of keyword pairs indicating which words should be found and what they should be replaced with is available in file 300. For example, the keyword AI should be replaced with the keyword collective. Each keyword will only occur once, but may occur in any order. Okay, yeah. So the fact that it will only occur once is good, because it means that we can, like, we don't have to worry about looping over a whole bunch. but it can occur in any order, so that's not too helpful necessarily. We could start with AI, search for AI, replace it, and then start over. Or we could simply, for each word here, we could go through this list, which would probably end up being more because herd is not in this list. So we'd 1, 2, 3, 4, 5. But we could search for AI with 1, 2, 3, 4, 5. So, we'd go through most of this. At most, we'd read this whole thing. But it does say they would all appear at least once. So we know we're going to be changing things. What is this? Also move file 200 to the outbox. So I think we'll just have you grab 200. Nope, you link 800, grab 200, link 800. Okay, so that moved file 200. We're done with that challenge. That's going to increase our network a little bit, but we'll see what that really means for us. So this is going to grab 300. Yeah, we're going to want a third bot. This is going to be our grab 300, and then we're going to mark loop here and mark what is it? Kill halt? Yeah, mark halt. Okay, so this one is simply going to copy M into T, right? Test T jump, or I should say F jump halt. We'll see if that works on words. We haven't tested that yet, so let's see if that works on words. If it doesn't work on words, we're gonna have to do some zeros. Now, you know what? We should avoid that. We're just gonna copy M into X because we are gonna need to do some tests. Test X equals 0, T jump halt, and then here we'll jump back to loop, or wait for the next word. And so this is going to be mark search loop. And in here, we are going to, right here, we'll seek negative. We'll go back to the beginning of the file. We're going to look for the word if not test X equals F, T jump found, or I guess F jump search loop. We need to seek one more. T jump found. Otherwise, we seek one jump search loop. It's going to increase our size a little bit. T jump found. No, mark found. We found it. We are going to copy F to M, and then we are going to seek to void F. We're going to remove them. We don't need them anymore. We don't need to search them anymore. And then that will reset, and we'll jump back to the original loop, and that should be that. We already, yeah, we do jump to halt. Okay, so here we are going to link 800. We are going to link 799. We're going to grab 212, which is what we need to modify, and then mark loop. We're going to work through it. Copy F to M, and then we'll get something back. Copy M to X, test. Actually, we can just copy that directly into T. We'll see if it works. So if it's false, which we don't handle false, when we come back out, we need to, yeah, if we break out, this is the not found scenario. So basically, it's gonna be a no-op, but it's gonna be more efficient to put that there. I don't know why I got rid of that. Jump loop. If we come out not found, we're just gonna say, I'm just gonna put that there, just so we have comments for ourselves. If it was not found, what we want to do is we want to copy 0 to M, and then we're gonna jump. Yeah, and then that'll do the seek up there. That way we don't have two seeks, because not every word's going to be found, so we need some way to communicate that. So F jump back to loop, we'll just keep going. If it was found, we will seek -1, copy X to F, and then we will jump loop, I guess, test EOF. Now we need to do that first. Test EOF. I think that's how it works. Yeah. T jump to halt. Not T. Yeah. This one will halt in a different way. So here we'll jump loop. And halting here, we have to copy 0 to M, and to tell the other one that we are done. And that's that. Let's see how we do. There goes file 200. All right, we've got herd. We send herd over. Now it's searching for herd. It doesn't find it. Cannot read past the file. We do not have that. Yes. Seek 1. And then we need to test EOF. Jump. Not found. Okay, cool. Yeah, so that can be there. That should work now. Let's alt click, right click, there we go. That puts us back at the beginning. And here we go. One sec, folks, 1 sec. And we're back. We are back. Okay, that was a quick one. Where were we at? We were dropping him. Searching for, what are we searching for now? We're searching for a paragraph tag. Greeting. Searching for Ghast. Searching for I'm. I think we're going way too fast at this point. Yes, we are. We are, because we have jump. Oh my goodness, we are skipping out. T jump. There we go. All right. That is now searching all the words. Let's see. We want to get to where we find something, so let's all click there. All right, we found AI. So we send collective over. It now has collective. That didn't false jump. Okay, so we seek back 1. We copied the wrong register in. That's not good. And then we, yeah, so we need to fix that definitely. It's in T. And then we jump back to the start. Okay, so let's try to run through this. This one's a time-consuming one because we have to search and replace. We don't have a way to easily do dictionaries. Oh boy. As we remove values from here, it gets faster, but that's worst case scenario is we still run through everything. All of the entries in here would be the last words in this would be the worst case. All right. Whoa, wait. We are... Why were we cycling infinitely here? Something's not right. Okay, hang on a sec. What's going wrong here? I gotta put a code here so I can alt click on it. So when is it told to halt? It is told to halt. Right, okay, so new test run, right? We're on test run 2. We go in. Okay. When is this one told to halt again? It is now told to halt, and we are continuing to run. Why? Why? We're not through with it. Has it finished? Has it finished its file? Is that the issue? We are EOFing out of this one, aren't we? That's fine. We want to play into test run number 2. It's too fast. Test run 2. I want to play this scenario up to where this tests EOF. Okay. It's breaking out sometime sooner. What I think is happening is we're getting to a point where we no longer have a value. This must be failing for some reason. So test EOF in the search loop. Then we need to... do we do it in the search loop? I don't think so. Test EOF. Then we just T-jump not found. That'll probably fix it. Yeah, that was it. That was it. Well, that was a weird one because we didn't really have a clear way to distinguish that. We are very high on size. Very high. We are very high on cycles. How is there a faster way to do this? That's what I want to know. How is there a faster way to do this? You know, I think I did it inverse of what we would want. Yeah, I think we did it inverse of what we would want. Let's try a new solution here. Okay. So, wait, why are we not? There we go. Okay, so we still want our 3. This one we'll just do in order, it doesn't matter. So we're gonna link 800, grab 200, link 800. That one's done, that one's easy. We're done with that. Do we need that to be its own piece of code? Technically, no. As a matter of fact, let's not. Let's do 2 this time. Because we'll do mark halt for our searcher, and it's going to link 800. Well, it's going to drop link 800, grab 200, link 800, and then it will halt. Before that, what it will do is it'll grab 300, and then it will copy F2M, copy F2M, and we're just going to do this over and over again. Mark loop. So we're going to copy both of them to M. We're going to test EOF if we're at the EOF. If we're not at EOF, we're going to F jump to loop. Okay, now down here, we're going to do something very different. We're going to link 800. So this new approach is we're going to send the values we're searching for. We'll search for it. We'll find it. We'll replace it. We'll start over. I think I originally said we were going to do this, and then I implemented the exact opposite. So this is going to link 800, then it's going to link 799, then it's going to grab 212, just like we did before. And then we're going to mark loop. We'll just call it loop. That's fine. Outer loop, I guess. So here, we'll copy M to X. So that'll be the word we're searching for. Then we simply mark search loop, and we'll do, we don't need this anymore, or not for now. We'll copy, what are we going to copy? We're going to copy something. We need to test F equals X, T jump found. If we didn't find it, we simply jump, we just jump search loop again. That's it. If we did find it, what we'll do is we'll copy, we've got a seek 1, seek -1, copy. We know it's going to be found, so we don't have to worry about it not being found. We're going to copy M to F, and then we're going to jump outer loop. So where do we test EOF? I guess we do it here. Test EOF. Well, I guess if there's nothing left to send that would halt, that'll halt. Yeah, that'll pause. There's a way to test if we can receive something. And what is it? I'm not going to bother turning it on because it's just one command. Test MRD. If the EXA could read from another EXA without pausing. Without pausing is very clear, but it should be waiting. The other EXA is not doing a lot of work. So test MRD. And if that is false, then we halt. And we'll mark halt here. And then we also need to test EOF, F jump halt. Which, I mean, I don't think this case is gonna happen. We'll probably run out of things to read. Even if they're at the end of the file at the same time, like, doesn't matter. We do need to start back over, so we need to seek all the way to the beginning of the file. Alright. Okay, let's try this approach. So this one's writing AI. That one reads AI. Now we start searching the document here for AI. Boom, we found it. So we seek back, we copy the replacement value in, which means up here we should be going back and we're copying network now. And here we go, we're copying network, we're starting over. Okay. Boom, 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 boom. It's already looking way faster. Yeah, we're down in cycle count to the average. Size is still a little high. Activity is high as well. How do we do it with less activity? How do we do it with less activity? We have one node. So I'm wondering, what if we just have this node do it? This is the one, so we don't need you to do all that nonsense. We don't need that. We're not jumping there. So if we link 800, grab 200, link 800. That's 1, 2, 3, 4, which is where we're at. So what if this REPL outbox? Then down here, below, above halt, we can have outbox that grabs 200, link 800, and then halt. Yeah, there we go. We lowered our network. And the size is the same. Cool. I didn't look at any other files while I was there. Nope. What that's like to have ethics. Yeah, it's confusing. Did you say they're blaming a hacker for those ATMs that went crazy the other day? A rogue hacker penetrated our system and caused several ATMs to distribute cash in an arbitrary manner. I wonder who did that. Couldn't have been us. We don't do that. We don't do that. Banks suck at code. Yes, they do. All right. Here we go. New issue of the magazine. Oh, hey, first timer. Welcome. All right, let's play this cutscene and get a new magazine.
Hey, I have some things for you. First off, yes, we got the next zine.
Hot off the press.
Someone helped me out. I had balance at the copy shop, but someone hacked it. Speaking of which.
Oh, what is it? A handheld game console. The Redshift.
People say this thing was underpowered, but it has its charm. This is its developer version. So you could make something with it.
Ooh.
In the game studio I worked for, I'll be happy knowing it's going to a good home.
Okay.
I'll deliver more zines now. I'll catch you later.
All right, cool. Okay, so now we can build games. Everybody loves games, game programming. Let's see, I need to get my magazines on the same tab here. Boom. Boom, okay. I don't think it's probably going to break. OBS is going to be like, I don't know what to do with this. But it's fine. Okay, KGOG-TV, Programming Hub. Compete with an opponent for control over a television station. Hey, alright, here's our first competition. We're going to join a hacker battle, but you never say anything in the chat room. Oh yeah, here we go. Hacker battles. Anyone want to battle me? I don't have my own server, but I took one. Find me at the TV station. I guess the only thing that really matters is your ability. In theory, it's a nice ideal. Okay, so hacker battles. That's a new concept in the game. Can I turn on... well, okay, why are we tiny all of a sudden? Oh, because I'm using the wrong... Whoop. All right, here we are. We're back. We're back in the right view. Okay, boom. Sorry for the weird... I'm just moving all over the screen. That's where I'm gonna be. Yeah, we got number 2. We got book number 2 here. Close that tab. Book number 2. So we're looking for hacker. To win this battle, you must make your movies play for longer than your opponents. A movie will play when the movie's file is the only movie file sitting in a channel host. Okay, so what do we got here? Hacker battle domination. Page 4. 2 players connect to a neutral battleground network. Each of them uploads their pre-programmed X's at the same time, which run their code and battle each other for the highest score. Each network features its own unique scoring system. There's a cycle limit. Each battle has a limit on the number of cycles that will be executed. When you reach the limit, the battle ends and the player with the most points wins. There's a storage limit. Each battle has a limit on the number of host spaces that your X's and drop files can take up on the network. Attempting to exceed this limit will cause an Exa to stall until more space is freed. One final tip: the state of the network during a hacker battle can be difficult to ascertain. Files will be moved around by your opponent's X's when you least expect it. Develop for flexibility, and maybe take another look at Ghast's article about error handling in issue 1. Runtime errors and how to exploit them. Okay, well, let's look at that. Hello, scrolling all of a sudden becoming super slow. Where's that one at? Runtime errors. Where there is there a runtime errors and how to explain? Am I missing it? Hacker. Oh, there it is. Page 12. Here we are. Sometimes X's try to do something that they're not allowed to do. When this happens, an X is automatically terminated by its host. It's functionally the same as if it ran halt, although most errors are boring and not useful. You can't divide by 0, so that blows up. Math with keywords. You can't perform operations like addition on keywords. Invalid F register access. Invalid hardware register access. Sometimes you don't know all the details of the host you're working with. Links can change. Files can disappear. There are some things you can only learn about your operating environment by attempting to execute code and potentially failing. It might strike you as messy, but it's not like we're working on some big software company where you'll be frowned upon. Invalid file X. Say if you're looking for a specific file, the Exa that tries it will terminate, but now you know the file isn't there. Yes, that is true. I now know that the file isn't there. Gain 1 point every cycle for each of your movies that is playing, files 210 and 211. Lose 1 point every cycle that a movie file that isn't yours, files 230, 231, and 265, is held by an Exa that you control or is sitting in your host. Lose 1 point every time one of your X's executes a kill instruction. Note that you may only battle your Steam friends after beating an NPC opponent. Okay. Well, I don't have any Steam friends to battle. Most people don't play these games that I know. So we will do the NPC opponent and we'll see where we fare. I know I've beaten it before, but can I do it again? Okay, so 210 and 211 are our targets. We are going to have to keep XA alive. So we've got 3 channels that we need to exploit. 809, 828, and 867. We've got 210 and 211 that we need to put on these channels. And then we've got 265 and 230 and 231 that we need to keep off of the channels. So we need 2 kind of X's that are constantly running. those that are taking 210 or 211 to a channel, and then those that are jumping into the channel and removing a 230 or 231. So let's get started with it. I think what we'll do is we'll start with delivery. We'll start with delivery. So the first thing that everything is going to have to do is it's going to have to link 800. That'll get us onto the storage. Then once we're on the storage, we'll have start delivery. We'll have let's have the file in X. That's fine. We'll mark delivery here. We'll grab 210. We'll grab X, and we'll link. I don't know, 809, or we'll link T. We can have both of them, every combination. That's fine. And we'll kill. We'll halt. Or we don't need to halt. We need to drop. Then we're gonna mark extract. We're gonna mark extract, and that's going to grab X, link -1, and halt. So that one needs to die as quickly as possible. So we can do a simple copy. What are our bad files? 230 into X, REPL, extract. Copy 231 into X, and REPL, extract. Copy 265 into X, REPL, extract. That's great. That's great. That gets the extraction in. That gets the start delivery in. I think I'm going to move extraction. We'll move extraction into another Exa. So this one's just spawning deliveries. And then we'll mark destroys. We don't need to mark destroy. Okay, so this one, while we're running, we're simply going to copy 210 into X, and then we're going to copy 809 to T, REPL, start delivery. Copy 828. Should be 809. Copy 809 into T. Ooh, that was copied from. Why was my mouse over there? Okay, copy 809 into T. Yeah, we're gonna overload. Copy 809 to T, copy 210, we're gonna REPL, start delivery. Then we're gonna copy 211 into X, REPL, start delivery. And we just simply do that. A couple more times. Because we've got 828 and 865. So we're just gonna try and basically bum rush in here, and then move the file onto a channel. So something's gonna move it back here. We'll keep spawning and moving it into a channel. one of them will catch it. If it wasn't caught by the first one, it'll get caught by hopefully a second one. And then we need our extractor. So it'll have an infinite loop as well. And it will have a mark extract. So it's going to link start extract. No. We can mark extract. It will link X, grab T, link -1, and then halt. And this will copy 230 into X. I feel like that's fine. 230 into X and copy 809 into T. You know what? Why? We can just do it here. This will link 809. That's fine. Yeah. Okay. So I was thinking we don't specify a port, but we do need a port. We do need to specify different kind of links here. This needs to go into T. Because if we do 809, 828, and then 867 in that order, if it goes to 809 and it doesn't find the file, it's going to die, which means it'll never go to 828. So we've got to spawn one for 809, we've got to spawn one for 828, we've got to spawn one for 867. And the same with the files. If we go to 809 and we look for 230 and it's not there, we die, which means we'll never look for 231 and we'll never look for 235. So, awesome news. Welcome to the show. So we've got to keep spawning like all this. This seems excessive, and it kind of is, but we've got to abuse those errors basically. We've got to abuse those errors. So, all right. Let us see. So we're going to copy that. We're going to REPL extract. So it's going to go try and extract that file. We're going to copy 8 to... you know what? I don't like it. Because we're already going to be on a channel here. So we just need to do it here. These are gonna keep spawning. No, I'm wrong. There we go. Okay. All right, 828. No, we're copying 231 into T. REPL extract. Go extract that one. We're copying 265 to T. REPL extract. Okay. And then simply copy all of that. So one thing that we can do is we can like mark a pair, I guess. And so that will do the copy 230T REPL extract. REPL copy 231 to T REPL extract. Copy 265 to T REPL extract. And we are jumping unnecessarily, but it shouldn't be that big of a problem at this point. Yes, that's a huge problem. We don't have a way to jump back. Never mind. I keep forgetting we are at a very low level programming language for challenge purpose. Okay, so we've got 809. 809 needs to be 828. And then 828 needs to be 865. We can reduce the number of the number of lines. If we copy 230 to T, and then we copy 809 to X, and we REPL extract. Then we copy 80828 to X, REPL extract, copy. It's not different at all. It's still three channels and 3 files. That's 9 total cases. I don't know what I'm thinking. Okay, so this is gonna loop through. It's gonna spawn a bunch of nodes. They're gonna go try and remove a file from channels. Then this one's gonna spawn a bunch of nodes that's going to try and grab a file and move it to a channel. Let us start working. So we've grabbed them. They are there. Okay. Well. Okay. I see. So we ran into a problem. We delivered 210 successfully to channel 9, and the AI opponent did not remove our video. So we never had the opportunity to move it somewhere else. So we need to not ever move 210. We need to pick one for 210. So we're gonna copy 809 into, let's keep it the same. 809 goes into X, copy 210 into T, and we're gonna REPL start delivery. Then we are going to copy 828 into X, and we are going to copy 211 into T, and we are going to REPL start delivery. And then we are going to jump. There we go. So that will keep 210 on channel 9, and that'll keep what is it? 211. Okay, so that moved a file there. Our B is not doing anything. Okay, yeah. So the first thing that we have to do is we have to link 800. So first, there's a bug. Fix that bug. Start delivery doesn't do anything special, so we're just gonna link 800, and we can get rid of start there. Okay. We've got a B. We did not swap these around. We are grabbing T and we are linking X. There we go. All right. Are we winning? Are we winning? Why are we not extracting from channel 6-7? Because we go to 865, not 867. Great. Okay. Okay, so we need to change our REPL extraction. So we want to target a file, and then we want to mark that. So we're going to do a start extract. Then we will link 800. We will link X, and then we will copy 230 into T, and REPL extract. We'll copy 231 into T, and we'll REPL extract. We'll copy, or then we can just grab 265 and link -1, right? No, let's just keep the pattern the same. 265, yeah, that one is 265, and we'll REPL extract. Then our extraction is simply grab the file that we think we're after, link -1, and then we're at the end, so we'll halt. This simply becomes copy 809 into X and REPL start extract, copy 828 into X, REPL start extract, copy 867 into X, REPL start extract. So that kind of creates a little bit more compact node. Why are we doing nothing? Who's stuck? We have hit the cycle count limit, haven't we? We have not. We have not hit the cycle count limit. We haven't hit the cycle count limit. Why are we frozen? Why is XA not spawning anything yet? We have an EXA limit, don't we? We have an EXA limit. Storage limit. There is a limit to the number of X's. That's what we stinking forgot. We stinking forgot that. Okay, we've got a limit to the number of X's. We are not being smart here. So we have one EXA, so it will link 800. Well, this is a tough one. This is a tough one. We only have 3 X's alive at a given time. We have no way of knowing if one has been destroyed. So I think one EXA needs to do more work, basically. This one needs to link 800. And then mark loop, copy 809 into X, copy 210 into T, REPL delivery, copy 828 into X, copy 211, REPL delivery, mark delivery, jump loop. Delivery needs to link 800, link, grab T, link X, and then halt. So that one needs to end as quick as it can. And then this one worker needs to do, but it can't. It can't. Mark, extract. Mark, run. Mark, extract, copy, 210, not 210, we don't want to remove 210, we want to remove 230 into T, and No, that's not. That's mark loop. Mark extract will then what will it do? I'm drawing a blank all of a sudden. Come on, brain. Let's get going. Okay, we want to extract. We want to copy 809 into X, and then we want to mark remove. Okay, so this is gonna REPL remove now, and halt. So mark remove is going to link X, grab T, link -1, and then that will halt. Copy 230T, REPL extract. Copy 231T, REPL extract. Copy 265 to T, REPL extract. Copy 8 to 8, X, REPL remove. Copy 867 X, REPL remove. We are again all stuck on REPLs because we're at the storage limit. We have no way of knowing we're at the storage limit. I think I'm trying to overthink this. The enemy's AI is pretty dumb. So I think if we just run through there, and then maybe we run through halting, and we jump over to halt, or not to halt, to extract. Mark extract, and then here we just halt, or mark end. Right, that should keep us from competing with each other for resources. Yeah. So we're copying 809. We're copying 210 into it, and we go to delivery. Then we copy 230 into T, and we REPL extract. Start extract. Then we I don't want to do both of the deliveries up front, but 230, 231. I'm doing it again where I'm covering up the code with the cursor. And then this pattern will want to run an extraction on 809 and 828 and copy 867 into X. Why am I doing that? Oh my gosh. That would be REPL start extract here, right? No. That is all just extract. We are taking away, we're having one exa that is responsible for creating X's. So we cannot deadlock. Because we are eliminating X's that create X's. realized we have remove. We don't need that. We simply have extract. We link 800. We link X, we grab T, and we link -1. Okay, let's try this. We grab our file, we move it there. We remove a file from that node. Why did it, oh, it jumped, ooh, way too far there. We need to jump loop. Okay. Yep. We never moved 211 onto channel 28. Why did we not do that? We copied 211 into T, and then we REPL delivery. We got REPL delivery got pushed all the way down there. Okay. Let's split our file, our links here, so we know where we're at. 827. Yeah, okay, because the first two get delivered to, and that just gonna keep running and run the cycle countdown. Boom. So they get some points, but then we quickly take the lead there. Yeah. All right. We S+. We won 100 times against the AI component after we struggled quite a bit to get there. Oh my goodness. Yeah, we struggled. Even after you forgot, you picked it right back up. What do you really want? That's it. Just a little hacking. All right. Well, who is Moss? Moss! Moss came into the TV station and beat me. So we are Moss. What if Moss is back? I thought Moss died. Ghast can confirm Moss is alive. Really? How do you know? Let's just say I'm pretty confident. Maybe because he's delivering us, what is it? The Trash World News articles. Why do you think Ghast gave you this? I guess he thought I might like playing with it, yeah. Is that something you do? How considerate of him. Such a nice guy. So this is actually a game engine within EXAPUNKS, which is really cool. There's an unknown 3-digit code, such as 473, that when entered 1 digit at a time into pass, will unlock the link between debug and secret. This is not what I thought it was. Find the 3-digit code and create a file in your host that contains the code as a sequence of 3 values, followed by the development kit's RDK ID. There is an unknown 3-digit code that when entered 1 digit at a time into pass will unlock the link between debug and secret. Okay, so we need to brute force the password. And then we need to transmit the code back. So step 1 is, I guess that's going to open up as link 800, maybe? I don't know. So let's get our brute forcer implemented. So we're going to start with copy 0 into X. Yeah, we're going to copy 0 into X. Then we will have fun with it. Okay, so we're going to link 800. We are going to mark main loop. And for main loop, we're gonna go through. We're gonna 0, 0, 0, 0, 1, 0, boom. So we're gonna mark test password. What that's gonna do is that's going to we'll do Swizz. We want to do so it's a 3-digit number. So we're gonna do 1, 2, 3. So that's the hundredths digit. X3, and then we're going to write that to pass. Then we're going to swizz X2 and write that to pass. So that'll be the tens digit. And then we're going to swizz X and the ones digit, and we're going to write that to pass. If that doesn't work, how are we going to know if that works? I don't know. Let's try 473 though, just out of curiosity. If we were to link 800, copy 4 into pass, copy 7 into pass, copy 3 into pass. So that should tell us what the code is. Oh, the code is 473. Yeah, so we're gonna try that out. Yeah, it is link 800. And then we want to find the 3-digit code, create a file on your host that contains the file, followed by the development kit's RDK ID, which is in file 199, looks like, which it doesn't specify here. So, yeah, so success will be we have to leave no trace, so we'd have to test for 800, and then that EXA is gonna die, and we don't have a way to know if that EXA died. So we don't technically have a way to know if that password was successful or not, which means that we'll have an EXA sitting there trying random passwords until it can link. One sec here. Which kind of stinks. We only have MRD as a test for can we read, which is very limited because it says, where's test MRD? Test EUF. Test if this EXA could read from another EXA without pausing. So if it would have to pause to read, it'll be false. Which means, like, we ultimately, because all of these things fail. I mean, it says that we could abuse the errors, how to exploit them, but you can't really exploit them because the exit terminates. So yeah, I guess we just spit out X's, and eventually one will come back, and the rest will die. And we'll have a bunch of wasted cycles, and it won't be ideal, but I don't know of a different way to solve that. So anyways, back to where we were with our password generator. Let's not link 800 there. We'll have you link 800. And then we'll link 800. And we can read the file. We'll grab 199, we'll copy F to X. We'll copy F to T, we'll drop. We'll link -1, we'll link -1, we'll copy, we'll swizz X3 into F, we'll swizz X3 2 into F, we'll swizz X1 into F, and we'll copy T to F, and then we'll be done. So the main loop here, I mean, we really don't need a second EXA. That solves everything right there. It's going to be the main loop. That's the core. So mark main loop. We REPL test password. Then we add 1 to X, and we add I X1 X. We store that in X, and then we simply test if X is equal to 1000. That means we've gone beyond 999. Then if we don't, we are main loop, and we can simply halt. Yeah, let's halt. So there we go. So we run that test passwords. I think we're barely just making it. Yeah, so that's gonna take forever. Why are there so many files here? See, that's what I'm saying. That is what I'm saying. So, like, if we grab a file, it's so rough. It's so rough. It really is. Because if it's not correct, then it's not going to... this one's tough. I'm gonna have to put in some kind of sleep. It's like it ran and it tested. Yeah, we're gonna have to put in some kind of sleep to get a signal back. So we're gonna run that. We're gonna REPL test password. Then we basically need to test if we've hit 1000. T-jump halt, right? So we can put a halt down here. Then here, instead of halting immediately, we will wait for a response. So we will copy 10 into X to T. Mark, wait. We'll copy 10 into T. We will F jump main loop. We'll sub I T 1 and then T. Boom. T jump. While it's true, we go back to wait. Once we're done, we test MRD. F jump. We go straight to main loop. And otherwise we will halt. Okay. So that's probably gonna be bad, which is fine. Oh, test MRD. If it's false, we'll copy. We'll void M. We don't want to do anything with it, and then we'll halt. Okay. So that tries 0, and we've just started counting down. We are constantly writing 10 into T. Okay. By the time that halts, we are at 9. So maybe let's lower you to 5. Once we get to 800, once we get here, we're gonna copy 1 to M. So we want to get here. We're trying a bunch of combinations. Boom. Oh, so we know the password here, so let's just test that out. We're gonna do 473 into X. I forgot we could just do this, right? So this is going to unlock it. It's gonna jump in there. We are still waiting quite a bit. So let's go back. By the time it jumps in there, we are at 4. So we don't even have to wait that long. Like, let's wait 3. It's in there. Because that's done, and then that comes back. Yeah, okay. Okay. Now, we can start at 0. And we can run these. Cycle count's bad, but brute forcing, we're brute forcing a password. How? How do we get a lower cycle count? How is the average cycle count lower? How? How? There is an unknown 3-digit code that when entered 1 digit at a time will unlock the link between debug and secret. Like how? It's an unknown code. We literally have to try every code. How? How are we doing this? We can't multitask. Yeah, he was a programmer. I wonder what that was like. It was fun while it lasted. I mean, he's making games, right? Alright, figuring out... yeah, so that wasn't the game. That was unlocking the game. Now this is the game. Cheap viewers, you are banned. Please do not advertise things that are against terms of service. You're really going to make a game with this? Why? I'm not offering a reward for it. Making something is its own reward. A sense of accomplishment. Alright, so we got our little game engine over, our little gameplay over here. We got our code over here. And we have our game network. This is the Redshift. There's actually a separate, free Steam game you can get that is the Redshift player, where you can play homebrew Redshift games that people have made. So this one is just creating something for fun. This level has no goal. So what I'm going to do is I'm going to pull up the Redshift instructions here, and we'll do something cool. The first important thing to grok about the Redshift is how to wait. This will likely be a familiar concept if you've done game dev before. The Redshift's VM includes a special wait instruction that isn't part of the core EXA programming standard. Executing a wait instruction causes the EXA to pause until the next frame synchronization, which happens 30 times a second. This makes it easy for a complex game to run at a fixed speed, regardless of how many instructions it takes to make your game. So to do what it's supposed to do. If you don't synchronize your EXAs with the Redshift, it'll result in a game that's way too fast to actually play, which, let's face it, could be funny. Data files. The Redshift's VM also includes, I guess we're going to be reading a couple of chunks. Let's turn the browser on. Yeah, so you can see the pretty pictures in it. So the Redshift's VM also includes support for another non-standard instruction, data. Data instructions are not executed, and in fact look a lot like notes, but are used to specify an initial file that will be held by the EXA when the Redshift initializes. A data instruction can be followed by any number of numerical values separated by spaces. If you can't fit all the values on a single line, you can make additional data instructions to specify the rest. The Redshift has a 120 by 100 black and white screen in 3D mode. In 3D mode, the white pixels can be separated into red pixels and blue versions, which makes them appear to sit above or below the screen. When viewed through the included 3D glasses, so if you have 3D glasses, then you can make a 3D game. I don't have 3D glasses. Unfortunately, the Redshift's 3D mode is infamously headache-inducing, and you shouldn't use it for long. All of the advertising and manuals for the Redshift suggest taking a break every 15 minutes. Each EXA has a 10 by 10 black and white sprite that can be edited when you're writing your code. The sprite can be positioned on the screen by writing numeric values to the GX and GY registers. GX offsets the sprite from the left side of the screen, while GY offsets the sprite from the top of the screen. If you must play with the Redshift's 3D mode, the perceived depth of the sprite can be changed by writing the value to the GZ register. The sprite can be changed at runtime by writing a 3-digit value to the GP register. The first digit indicates the operation, 0 off or 1 on, to toggle, while the second and third digits indicate the pixel to change. We've got a built-in font, but wait, there's also rudimentary support for text. Writing a value in the 300s to the GP register causes the entire sprite to be set to a character in the Redshift's built-in font. So 300 is space, 301 is an A. So if we tried that over here where we copy 301 into GP, right? Whoops, we don't want to create, we just want to run that. So that puts an A in our graphics, our sprite there. Sprites can overlap each other, which is defined as each sprite having a white pixel at the same location on the screen. When this happens, each X's collision input register will be set to the value in the CO collision output register of the EXA it's colliding with. So I wonder if we had multiple EXAs that did, right, where pad X, pad Y, I guess we could just sit here. So we could do copy 301 into GP, and then we want to copy, 0 into GX, copy 0 into GY. We get an A on the screen, and then if we copy 302 into GP, what is this? This was, what size was the pixel register? 10 by 10. So we simply want to copy 10 to GX, and we want to copy 0 to GY. So that should print a B on top of each other. So we have to do I wonder why. Oh, because it's writing that sprite onto the screen. Yeah, so each one of these has to be a sprite. Cool. What do we got? Let me check chat. Chat is quiet. Okay, that's not promising. We got a collision system, so it'll set so no collision. CI is -999. CI is -999. These are not colliding. No white pixels touching. These are colliding. The Redshift has 4 audio channels, so we could play music. The pad X register indicates the horizontal state of the D-pad, so we can receive inputs here, and we can receive values here, and simply read those. So interestingly, we could have a program here where we render, and then we What do we do? I don't think we can, yeah, communication's still pretty rudimentary. So what this needs to do is this needs to link 800. It needs to go up there. And then we'll just mark loop. Mark loop, right? We got our game loop. We'll jump loop. And of course, right before we jump loop, we're just gonna wait. That works. So we've got copy 301, and we can have a message. So let's do the quintessential programmer game. Oh, but we can't. We can. We'll figure it out. So we've got 300 and well, let's turn this off so that we can see everything on screen. Where are you at, OBS? Okay, there you are. Let's turn off the browser. Let's get back to, because I need to reference that. So we want to do 308, 305, 312, 312, 300 and not 12. And 15. Then we're gonna do 300. 300. Those are numbers. 23. 315. 318. 312. And we got 304 and 300. 339. Okay. So what the data does is if we start, you see we now have a file attached that is that. I don't know what you're doing. We don't need to link 800. I was gonna do, well, you know what? We are gonna link 800. So we are going to not do this anymore though. We will REPL draw. So we'll copy F into X, mark draw. Draw that. Test. Draw. Okay. Test EOF. F jump. If we're not at the end of the file, we'll go back to draw loop. Yes. We also need to copy 10 into T. Copy 10 into X. Nope. Copy 0 into X. Yes. Yes. We still don't have any other registers. And then that's gonna draw. F jump draw loop. We will add I10 to X to X. We'll add to X, 10 to X. Okay. We're gonna copy that into T. We're gonna go to draw because we're gonna overwrite T. We need to keep X, and then in our draw, our little draw REPL, we're gonna mark draw. We're gonna copy X to GX. Copy. We want to add 100. Yeah. 1,000 because it's by tens, right? We want to swizz X. We want, so it's going to be 2 digits for X. That's not going to work. It's not going to work because we do have 3-digit numbers. That's unfortunate. That's unfortunate that we cannot draw the same value. Yeah. I don't know how we're gonna draw this. But at least not the way I wanted. It's fine. We're just gonna do the original non-interactive way. So draw is going to copy X to GX, copy 0 to GY. Then we will EOF. Not EOF, we will halt. Right, so in theory, you know what? We never did that. We need to copy T into GP. Yeah. So that creates H. That writes an H to the screen, and then it dies. And for some reason, that is putting O's. I don't know how we're supposed to write a game. I don't know how we're supposed to write a game when we can't draw a word. Okay, well, we drew Hello World. It didn't work that great. Which stinks, but it's a whole thing. Yeah. So we just simply, you keep holding the button, you better be telling the truth. I mean, I built something. Yeah, nothing special. Anyways, continue the discussion of morality with Ember 2. I guess what we'd want to do, let's just hop back in here. So since we're kind of done there, we can just do, like we'll do a ball, right? So we can do like a ball shape. Like that. Of course, I want it to be a little bit smaller. So let's turn these off. Boom. 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 Nope, we need to put, there we go. Because these need to turn on. These off, this off, boom, boom. Yeah, okay, so we have a ball. So we can mark, so we are gonna link 800. We're gonna mark loop, and then we're going to jump loop. We are gonna wait at the end, and then we'll have our Y value. So if where's our input reading? Where's our input reading? The input system pad X register indicates the horizontal state and pad Y. So pad X, we will add I pad X, so G X pad X into GX, add I GY pad Y into GY. Right, and we're going to start off with copy 0 into GX, copy 0 into GY. We'll start off there. And then that'll draw, and then we'll wait. And so if we run it, we have a ball on the screen that we can now move around. Boom, 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 boom. Isn't that so exciting? We can now draw a ball on the screen. And we could do... Oh, nice. It turns everything else off. We don't do anything if buttons are pressed. We do go off screen. So yeah, there's a lot more work that we could do in here ultimately. And it does look like these registers persist, which is nice. But anyways, okay. Now we've legitimately done something with the game. We read input, we draw a ball, we move a ball. Continue the discussion of morality.
I have a real question to ask you. Say there's a trolley on a track heading toward 5 people. 3 of those 5
we're doing
people
this
are
again.
vegetarians.
Okay.
There's a switch you can throw that will shut down a meatpacking facility that is located down the road.
Okay, we've got 3 people that are vegetarians out of 5 on a train track. We have a switch that will turn off a meatpacking facility.
The switch will also prevent the train from stopping because...
So it stops the train.
Wait, I may have reversed something. Recalibrating. There are too many variables here. Okay, let's return to this later. I need more data first, and I need more
the trolley problem is hard to come up with, I guess. So, whoops, whoopsie. I don't have an answer for the trolley problem yet. Anyways, what do we got? You ever think about how society has advanced, like how far we came in the last 100 years, and how it'll only get better, faster? Technology is accelerating. People still suck. Copy requested books on various topics. Time for research. Human physiology, human morality. Your usual topics. Wait, am I really predictable? I'll have to change things up. Let's get books. All right, we've got the Palo Alto Digital Library Project. Books are stored in the host corresponding to the first digit of their call number. While a book's file ID is 200 plus the last 2 digits of the call number. For example, book 512 would be stored in the host 500 to 599 as file 212. Okay. So if we link 800, I guess we can link interchangeably. This just says 800. Okay. The call numbers for the books once are available in file 300. Note that Ember will never request more than 1 book from the same host. Okay. So what do we need to do? Duplicate each of the books requested by Ember and bring them back. Okay, so we're gonna do some spawning. We'll grab 300 and then we'll mark loop test EOF. We'll copy F to X and we'll test EOF. And if we're not at the end of the file, we'll jump there, otherwise we'll halt. And the reason why we're gonna halt is here we're gonna REPL copy. So this is gonna mark copy, this is gonna go out and copy the book. So we've got the target in X, and we know what host number it's on. It's gonna be on host number 5. So we're gonna go ahead and swizzle that. We're gonna swizz that out, so that's gonna be the hundreds digit. So 1, 2, 3, right? So 3. Yes. So X3, and we're going to put that into T. Then we're going to go ahead and change X to the file number. So that's going to be Swizz X021. So we want the 1 and the 2s. So 1s, 10s, and then that'll go back into X, and then we'll add I 200, X 200 to X. Cool. We have that. Now we can actually go out and copy it. So we're going to link 800. Link 800. That puts us in the 100s. So what we should probably do is, you know what? We don't need to do that. Okay, so we're going to mark find node, or host, I guess. Ooh. We're gonna have to know how to get back. Yeah, I just realized that we don't want to replace this with a file number just yet, because we're gonna need to know how to get back. We are gonna want to extract that out, but we're not gonna want to replace it. Yeah. Find the host. Find the host. Oh yeah, we're not gonna do that. So we're gonna link 800 sub I T -1 store into T, and we're going to T jump. If that's still true, we're gonna continue finding the host. Once we're on the host, we will now get the file identifier. So we will mark transcribe. We'll see what that is in a minute, because we're gonna have to write to a file while we're reading from a file. So we need to get the file ID. We're gonna Swizz X. We're gonna take the 2-1 out of it, and we're gonna put that into T. We're gonna add I 200 T plus 200 to T. Then we will, what are we gonna do now? We are going to grab T, and then we'll REPL transcribe. We need to toggle local. So there's a command that we haven't really used yet, because we've mostly done global communication between X's, but we want to do local communication. So we're going to swap modes. None of these are going to be global, so we're just going to simply, we can just flick it here, and then we don't have to worry about it. All right, so that's going to allow us to communicate locally. That because now we're going to read. The transcribe is going to make a new file, and then it will mark T loop. We're going to copy M to X, because we're gonna have to test it. Test X equals negative, we'll just say negative 999. Because I mean it's words that appear, but we do have numbers. So it's not test. If it's negative 999, we're done. So if it is, then we'll return. So let's mark a return. We'll write our return code. If it's not negative 999, then we need to copy X into F. We need to do that before we jump to loop. Copy X into F. This is going to mark read loop. Okay. And what we're going to do is we're going to test. I guess we'll just copy F to M. And we'll test EOF. If we're not at the end of the file, so F jump, we simply return back to the read loop and do that again. Otherwise, we will, what is it? Okay, once we're done, we're going to copy negative 999 to M, and then we're going to halt. Okay, so now that we're on the return journey, I just realized we can't use, we're going to have to use T, which is fine, because the value of the result of this test will be written to T after we test it. Oh, but then we lose the value. So copy M to F, seek -1, test F equals -99. If it does, return. Otherwise, jump T loop. So if it does, we're going to seek -1 and we're going to void F. So we need to delete it from F. Then we're going to take our handy dandy, how many times we need to get back. We're going to copy, we're going to swizz 3x against 3, and we're going to put that into T. Then we are going to mark return loop, link -1 to get out of there. We're going to sub I T1 into T, and we're going to F jump, T jump, and to return loop. Once we're here, we're going to link -1 and we'll halt. That is a lot of code in 1EXA. Let's see how it goes. So we have spawned 512. So what we'll do is we're just simply here, we're just going to halt after the first copy so we can follow that. So that goes to 800, where it has swizzed 5 into T. So we now link 1, 2, 3, 4, 5. Okay, where we grab the file. We grab the file that we were looking for, which should be 212. That's correct. We spawn the reader. We have a reader over here, or a transcriber. And so it's writing 512. It's testing 512. It's testing. All of this to leave 512 available. And that way we're just reading it into the file. I just realized the first line of the file is the value that we want, right? All of these files, like 171, file 271 is where are you? 271 right there. I think I can click on it. Oh no, whoop. Okay. So 271 it's right here. 271 has 171 in it because it's on node 171. Okay. So you know what? We don't have to do all this seeking. This is going to be a performance hit, guarantee it. So we're going to copy M to X. We can test X. We're gonna test X, and if it's not, we're gonna copy X to F. So we can do that, and then once we are done, we're gonna simply go to return. What it's gonna do is it's gonna seek 9999, and it's not gonna void it. It's going to swizz that value back out. Into T, and we should be good. Okay, so we go read, we go to our 5th node, we spawn, we write a bunch of data, boom, 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 we're writing data, We are pausing. Comma, dot. We are done with the file. So our reader writes 999. That gets read, and then we halt. Then over here, oh, that one halted. So now we're back on 00. So now we do tjump return. That seeks to the beginning of the file. That gets our 5 out. Then we simply go back, where we do one more go back, and we halt. Of course, we don't need that final halt because we are done. And that should be, and then we should remove this halt so that we don't end prematurely. We've got all of these working out here simultaneously. So we just run out there, we grab all the books that we want. We're good on cycles, we're average on everything, really. There are improvements that could be made, but I don't know what they would be. Like, these improvements have to be, I don't know, like one pass. That's a tough one. All right. Moving forward. What do we at? Well, we're at 806. We'll try and do one more, and then we'll call it processing. Yes, this is what I wanted. You read them all already? Maybe. Is that weird? I mean, she's an AI, so. I guess. It doesn't really identify as a gender, I don't think. By analyzing patterns of word recurrence and deriving correlations between concepts implicit in statistically significant word clusters. I'm hungry. What are some good snacks? I hear X10 loves Peanut Blast without the peanuts. Remember? No peanuts. Still can't believe they messed that up. I would try one. But they don't have Last Stop out where I'm at. You must live in the boonies. TEC Exa-Blaster Modem. I've been analyzing television and radio broadcasts, and I have a few questions. First of all, why do some things become popular while others don't? The masses like anything? So it's whatever people happen to pick. We should test this. Think we could pick a random pop song and make it a hit? I don't know. Could we? Connect to each radio station and replace every song in the playlist, file 200, with Can't Not Get Over You by ME2U, which is in file 300. Each song in a playlist consists of 2 keywords, the song name and the artist name. A list of phone numbers for the radio station is available in file 301. Note that Exas in global mode can only communicate if there is a path of links connecting them. Okay. Which means that these radio stations aren't linked up. So what I think we're going to do is if we look in manual number 2, there's going to be, I guarantee you, there's going to be a thing about radio stations. Modem control at the direct level. Is that, hacker skills, yeah, modem control at the direct level. Boom. I did not even look at what page that was on. That is on page 18. So now we can go to page 18. And modem control at the direct level. What kind of control are we talking here? Well, all Netronics compatible modems have a dial register right there that takes 1 digit at a time that can be used to programmatically dial a phone number. After establishing a connection and assuming that there's actually a computer at the other end that wants to talk to you, you should be able to traverse the 800 link to connect to a remote host. Writing -1 to the dial register hangs up the modem. If you're connected to a remote network, this will break that connection. So we've got 2 values that we have to write, so we can't simply store them in memory. But we are going to have to make a copy of the file. 301 gives us phone numbers, so that can be the dialer. So yeah, we'll have an EXA that does the dialer. So we'll grab 301, and numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 digit phone numbers. A list of phone numbers for the radio stations of file available in file 301. There's 1, 2, 3, 4, 5, 6, 7, 8. There's 1, 2, 3, 4, 5, 6, 7, 8. Yeah. 11 digit phone numbers. All right. So this will mark dial loop. And then we'll copy 11 into T. And we'll mark dial. So that'll copy F into dial. We need to link 800. Copy F into dial. Then we're gonna sub I T by 1. If that's false, we're gonna F jump. If it's true, we're gonna F jump dial again, and once that's false, we'll be back out, where we will jump dial loop. We can test EOF here, and we'll F jump that to dial. Okay. If we are done, we will wipe and what is it? We're gonna wipe and wipe and halt. It'll automatically halt. Okay, so that's gonna dial. We need to send a signal to the EXA on here. So it'll receive a signal, then it'll globally transmit that the next one is good to go. So this one will only communicate locally, and so once we have dialed, we will simply say we need to do the EOF test. Do we need to do the EOF test? Once we have completed the dial, we will copy 1 to M, because we're just basically saying go for it. Okay. You are going to grab file 301. Then we are going to mark spawn loop, and we're going to mark go, I guess. I don't know. Can't think of names right now. My name maker's breaking down. Okay, mark spawn loop. So we are going to spawn a new one. The new one is going to make a file, and then we'll start in local mode. So it will make a file. It will copy M to F, copy M to F. Then it will link 800. We're gonna void M, so we're just gonna wait until we're told that we can go. Then we're gonna swap modes. We're gonna copy 1 to M. We're gonna link 800, and we'll go from there. All right, so spawning is going, we've grabbed file 301. We are going to REPL go. We're gonna copy F to M, copy F to M. Once we've done that, we're going to swap modes, and we're gonna void M. We know there's 8, so we're gonna copy 8 into T. We're gonna sub I T1 T T jump. We're gonna go back to spawn loop. We're gonna switch back to mode, back to local mode, and we're gonna T jump spawn loop. So that rebels go. That copies FM, and gets it on its way. And we'll halt here. Okay. So we've got XA waiting. XB died immediately. Or XB died immediately. What is XB dying? Okay, we're grabbing 301. We're grabbing 300. You are grabbing 300. Okay, so that is dialing. That is dialing. Boom, we have connected to a host. We now copy one to M. So our XB0 here now voids that. Switches to global, copies one to M, links 800. And then our dialer is in the process of dialing another number. But I didn't open a new connection. Okay. So we need to go back to modem control and figure out how to close a connection. This should be the physical switch on which the modem to the remote host. Writing -1 to the dial register hangs up the modem. Okay, so we should vacate quickly. So it's gonna copy, it's gonna link 800, and then it's gonna wait. Then we're going to link 800 immediately. Then we're gonna switch modes to global. So that's waiting on the dial. The connection's open. We hop over there. We didn't change this to hang up yet. That's gonna copy -1 into dial. That will hang up the phone. So we're basically saying, you go, it goes, and then we kill the connection. And then it waits for one global. Ooh. Yes. We don't want this one to do that because it's no longer connected to the same node. I mean, it gives you the hint here, like literally. You can only communicate if you have an active connection. That EXA is now completely disconnected from our main network, so we cannot send. What we can do is we can swap modes here, copy one M, and then swap back to local mode. So that'll free it up. So that goes while we're dialing. While we're dialing, that gets over there. We tell it, we get another one, and then it died. Why did it die? Why did it die? We're watching A, we're watching B, we're watching B. So it is waiting to be told to continue. It swap back to local. It copies that. We need to seek. Hello. Okay. Once we are here, we need to seek -9999. Yeah, we need to seek back to the beginning of the file. Okay, so the dialing is working. That's all working. Now we need to work on the replacing. So we're gonna REPL replace, mark replace. This is where once we're here, I think, yeah, we still REPL replace. And then mark replace. We're going to grab file 200, and then we're going to copy 1 to M. we're going to copy M to F, copy M to F, test EOF. If we're at the end of the file, if we're not at the end of the file, so false jump, we're going to go back to replace. If we are at the end of the file, we're going to copy 0 to M, and then we'll halt. And then this one, once we get into replace, we'll mark copy loop, I guess. It's going to copy M to T, and T jump halt, or I should say F jump halt. Otherwise, it's going to copy F to M, copy F to M, seek -9999, and jump copy loop. Okay, so we need mark halt. Okay. So once we get a connection, once we get an exa over here, so we've got B0. Let's collapse some of these so we can track them better. Okay, we've got B0. B0 is copying 1 to, okay, we still have that in there? I thought we got rid of that. Once we are on the remote file, like, we're done with waiting. Okay, we're waiting on the dialing. Dialing. We are connected. We spawn. That grabs the file. It says where it go. We can collapse you now. So XB0 is our copier and XB00 is our replacer. So it's saying, what just happened? I wish there was like a go back one command, but there's not. We want to get to this point. So rep will replace, this copies M to T. Well, we've got 1. Okay, so we copy F. We're at the end of the file. So let's move this seek to the beginning of the copy loop, and we don't have to add it to multiple places. So we should get here. All right, now we're gonna copy MT. So that's a 1. So we don't halt. We copy the name and copy that. Then we go back, we wait. That one can't grab a second file. Why are we grabbing a second file? Mark replace, okay. Mark replace loop. Yep, all right. Boom. Now we're grabbing that. We're writing that in there. We're writing that in there. We're writing that in there. At this point, we've got another one connected. Okay, so let's. What's the state of the system? 404. We are not. You need to wipe. When you jump to halt, okay, you jump to halt. Let's move halt here. Wipe, and then we'll have to actually halt. Yeah, because we were leaving a file there. Boom. Okay, we did okay. Couple averages on cycle count. Activity's up. I mean, how do you get lower activity? We literally only do, I don't know. That was surprisingly easy. People are requesting the single, humming to themselves, buying an album just because they've heard it before. Is that really all it takes? Mass media is a sham. I don't know. Girl, you need to get a clue. Just can't get over you. Oops, I guess it's pretty catchy. Okay, let's go here. So one of the thoughts that I just had is if we take... No, because we still need that data from XA. I'm wondering, though, we could move some of this logic. We'll leave that as an example or as a potential upgrade that we can do for the next stream. On, what is today? Today is Tuesday, so I'll see everybody on Thursday. Where we'll pick back up and maybe try and improve that one, or we'll just continue forward with more of these. Oh, look, they all have phone numbers. Whoop, I did not mean to click into that. Okay. All right, well, thanks for tuning in. Anybody who tuned in, I really appreciate you being here. Appreciate your time, spending that time with me. Thanks for anyone who participated in chat. Yeah. I'll see you guys see you folks on Thursday. Cheers. I gotta find OBS and